This is a homework help on lesson 8.1. And here we are dealing with systems of linear equations. And we're wondering whether this ordered pair is a solution for both of these equations. So the strategy for doing it would be to write the equation out, leave parentheses where the x value and the y value will be placed. And now we're going to put the x value as a -1, the y value as a -1, and for the second equation, x value -1, y value -1. So this is a -5 plus a -5. Does that equal -10? Well, yes, -10 equals -10. And this is going to be a +10. And this is a +10. Does that equal 20? And that does. So this is a yes. Now, in this next example, we're given a rectangle. And you might think of a rectangle here, where the dimensions are 20 meters longer than its width. Find the dimensions of the rectangle. Let x equal the length and y the width. So the equations have been set up here. And what you're asked to do then is to graph these equations by converting them, they're in standard form, to slope-intercept form. So that's what we'll work on. So we want to solve both equations for the letter y. So here I'm going to leave the 2y there, transpose this 2x to the other side where it becomes a -2x, and then plus 120. Now I'm going to divide everything by 2 to solve for a positive y. So I now get y equals, this is going to be a -2/2, which gives me a -1. I don't write the 1. I'm just going to put the x there. And this is plus 60. And that's what I'm going to put into this equation. Now, here I've put a -1. All I needed to do is actually just put the negative, but you could put the -1 apparently, because they accepted it. And then that graph will form. Now, for the next equation, and I'm going to get rid of some of this so it doesn't affect our work here. Here I have a -y on this side, so I'm just going to take that y, move it over to this side where it becomes positive, and I get x. I'll move the 20 over, and then I'll rewrite it. Y equals x minus 20. And again, you didn't need to put anything there, but I guess they're allowing us to put the 1, and there it is. Now, when this forms, the second equation will form. And now you are to read from the graph, what is the point of intersection? Well, the point of intersection for the x value is 40. You can see that right here. And then over here, 20. And that's what you put there. So they're saying the y is the width and the x is the length. Now, for this one, we're using the same protocol. we are to put this in slope-intercept. It's in standard form, and the same for this. So again, we'll isolate the 2y, transpose the negative 2x to the other side where it becomes a positive 2x plus 8. Divide everything by 2, and we get y equals x plus 4. All right, we're going to do the same thing here. The y is already isolated. Just transpose the negative x to the other side. It becomes a positive x, and then a negative 7. That's what the answers were in the answer box. And the question is, what do you note about these? Well, as you look at the slopes are the same. As you look at the y-intercepts are different. And then from chapter 6, you may recall that when that occurs, the lines are parallel. So would there ever be an intersection? So no, it's not consistent. It is inconsistent. And you can't see that little dot down here, but that's where you would put it, inconsistent. Now, another example was similar to one we've done already. The equations were in standard form. We had to put them in slope-intercept form, fill in our values, and then look for our point of intersection. Because once you put your values in the graph's form, and an x value was 15, and then going up, our y value was 35. So we've done one like this. Now, for another kind of example, here they're giving you the graph, they're giving you the equations, and they're in a sense asking, are these graphs formed properly? So what is our point of intersection here? What's our ordered pair? Well, our x value is going to be a negative 2 right there, and our y value is going to be a 0. So we put that in here, 2 times negative 2 minus our y value, which is 0. Does that equal negative 4? Well, this is negative 4, negative 4. So this one checks. How about for this one? Well, again, 2 times negative 2 plus 3 times our y value, which is 0. Does that equal negative 4? Well, again, this is negative 4. This is 0 equals negative 4. And the answer would be yes for this type of example. Now, we've done one like this already, where again you solve the equation for y. It's in standard form, and the first one becomes this. And the second equation, again, solving it for y, we've done some like this already, becomes this. And then you look for the point of intersection, which is a 3 and a 2, and you put that in there. So again, we're going to keep this around 10 minutes as a short review, and hopefully helpful for you.